Have you ever wondered why a rubber band stretches but a glass cup breaks? Or why your sweater keeps you warm while your silk scarf feels cool against your skin? In today's story, we'll take you on a magical journey where everyday materials come to life. Watch as young students discover the hidden secrets behind the things we use every day. So, what makes the perfect material for the job? Let's find out together. It was a bright Tuesday morning at Riverbrook Primary, and the air buzzed with excitement. Today, the class was visiting the Lab of Wonders, a magical science lab known for its curious experiments and mind-boggling discoveries. Mrs. Patel, the science teacher, had promised the students that they would learn something truly amazing about the materials all around them, things they saw every day but had never thought much about. As the students shuffled into the lab, they were greeted by Professor Marlowe, an eccentric scientist with wild gray hair and a twinkle in his eye. He wore a white lab coat, splattered with colorful stains from past experiments, and his glasses perched on the tip of his nose. "Welcome, young scientists," Professor Marlowe exclaimed, clapping his hands together. "Today, we are going to explore the fascinating world of materials. What they are made of, how they feel, how they look, and what they can do." The room itself was filled with shelves lined with jars, boxes, and containers of every shape and size. There were smooth wooden benches, cold metal stools, and shiny glass beakers. The air smelled faintly of fresh paint, rubber, and wood, filling the space with the promise of adventure. Now, materials are everywhere. They make up the things we touch, see, and even wear. Each one has its own unique properties. Professor Marlowe continued, his eyes shining with excitement. He reached into his pocket and pulled out a small brown cloth bag. "We'll start with something simple. Everyone, gather around and close your eyes." The students crowded around the professor, their eyes tightly shut, waiting in eager anticipation. "Now, I want you to use your sense of touch to describe this material," he said as he handed a small object to each student. It felt soft, yet stretchy. Rosa, one of the most curious students in class, was the first to speak. "It feels smooth and kind of bendy, like a rubber band," she exclaimed, squeezing the object between her fingers. "Good observation, Rosa," Professor Marlowe beamed. "That's because it is rubber. Rubber is a flexible material, meaning it can stretch and bend without breaking. It's often used for things like tires, erasers, and balloons because of this property." Mrs. Patel nodded, her eyes twinkling with pride. "Rubber is perfect for things that need to be elastic or durable. Imagine if car tires were made out of glass. They'd shatter every time we hit a bump." The students giggled at the thought of cars with shattered glass tires. Next, Professor Marlowe picked up a shiny silver spoon from a nearby table and held it up. "Now, what do you think this is made of?" he asked, passing it around. Jaden, a tall boy with glasses, turned the spoon over in his hands. "It's cold and hard, and it's shiny. I think it's metal." "Correct," the professor said. "Metal is often hard and strong, and it can be shaped into many different things, like spoons, forks, cars, and even buildings. Metals are used because they are durable and can hold their shape." Then, Professor Marlowe reached for a transparent water bottle sitting on the table. "Now let's take a closer look at plastic. Plastic is lightweight and can be see-through or solid. It can feel smooth, like this bottle, or sometimes rough, depending on how it's made." "Plastic is everywhere!" exclaimed Amelia, twirling the bottle in her hands. "Yes, Amelia, it is. And plastic has the advantage of being cheap and moldable, which is why we use it for so many things. Bottles, bags, toys, and even some parts of your smartphones. The professor then handed out pieces of wool, cotton, and silk for everyone to touch. These are different types of fabrics, he explained. Wool is scratchy but keeps us warm. Cotton is soft and breathable, and silk is smooth and shiny, perfect for fancy dresses or scarves. Each student ran their fingers over the materials, amazed at how different they all felt. "And why do we use wool for sweaters but not silk?" asked Rosa. "Well, Rosa, wool is thick and traps heat, so it's perfect for cold weather. Silk, on the other hand, feels light and cool on your skin, so it's better for something like summer clothes." The students were beginning to understand that different materials had different purposes depending on their properties. Professor Marlowe's next task was to show them how these materials could be matched to the right job. We know that glass is see-through and fragile, which is why it's used for windows but not for footballs. You wouldn't want to kick a glass football, would you? He asked with a chuckle. The students shook their heads, laughing. "But what about this?" Professor Marlowe held up a sleek wooden chair. "Why do you think we use wood for furniture?" "Because it's strong but not too heavy?" Jaden guessed. "Exactly." Professor Marlowe smiled. "Wood is sturdy, and it can be shaped into many things, like chairs, tables, and even houses. It's also not as heavy as stone or metal, which makes it easier to move around." The students were clearly fascinated by how materials had to match their purpose. Professor Marlowe clapped his hands again, and the room dimmed slightly, as if setting the stage for the next big reveal. "Now for the grand finale," he said in a whisper, his voice filled with mystery. "We're going to see how combining different materials can create something even better." From a cabinet, he brought out a strange-looking machine, full of pipes, wires, and gears. It whirred and clicked as it came to life. "Behold the Material Matcher 3000. This machine will show us what happens when we combine materials with different properties." The students watched in awe as Professor Marlowe fed a thin metal sheet and a piece of rubber into the machine. After a few clicks and clatters, out popped a shiny metal plate with a rubbery surface. "Now, what do you think this might be used for?" he asked, holding up the object. "Maybe for something that needs to be both strong and flexible?" Jaden suggested. "You're absolutely right. This is similar to the material used in car bumpers. The metal makes it strong, but the rubber coating allows it to absorb impact. This way, if you bump into something, it won't shatter or break easily." The students were in awe, impressed at how combining materials could create something new with even better properties. Before the class ended, Mrs. Patel guided the students to a workstation where they could apply what they had learned. "You will each be given a task," she said, "to choose the right materials for a specific job." One by one, the students were given simple challenges. Rosa's task was to choose a material for a raincoat. She picked plastic, knowing it was waterproof. Jaden had to decide which material to use for a frying pan. He chose metal, recognizing that metal can handle high heat without melting. The classroom buzzed with excitement as the students made their choices, showing off their new understanding of materials and their properties. As the class came to a close, Professor Marlowe smiled proudly at the students. "Remember, young scientists, materials are more than just things we use. They are part of everything we build, touch, and experience. The right material can make all the difference." Mrs. Patel added, "The next time you see a chair, a spoon, or even your shoes. Think about what they're made of and why. As the students filed out of the lab, their heads were full of ideas, their curiosity sparked by the wonders of the materials all around them. They had learned more than just science that day. They had learned to see the world in a new way, where every object told a story of its own. And who knew? Maybe one day they would be the ones inventing new materials, solving problems, and creating the future. The Lab of Wonders had done its job. It had opened their eyes to the magical possibilities of the everyday world.